Okay, looks like Twitch data, YouTube's getting data. Yep. YouTube one doesn't seem to go through all the way. Okay, hopefully we queued up with all the messages. So today we have an ARTY board here, and the USB is too small, but we have an ARTY board. We're going to learn how to do fault injection on it. Okay, so let's go ahead and dig into the fault injection. So to do this, we have a tickle script, this guy. But I need to make sure it's up to date for what we're going to do in this one. So basically, I just want to make sure our read and write are good. Okay. So first thing, we have to make sure our frame size is right for this. So we're gonna do 101 and JTAG. We'll have to specify. Okay, it looks like we're gonna need to get the ID code. So let's go ahead and pull up the FPGA. Probably get to the right directory, so we're gonna cool. But we're gonna put XSDB here. Connect. We want our JTAG targets. Okay, this is the ID code that we want to live. And it's going to be, if we look at our directory, I already have the FRAD to be that name right there. Okay, and we have no pblock info. Should be. Yeah, we want to do 102 words. There's gonna be no big pipe. Read. Okay, we have to fix that one. And where's this? I want to try to find where this big pipe was. So yeah, this, we need to go fix that so it matches this. So let's go to read raw frame. So we have refra bin. Okay, cool. And we put a 10 plus there. We don't want that. I think we can just, copy this here. And where was the next config pipe? Okay, right frame hex. Or yeah, right frame hex. Right frame. That should be good. That's my own test. So worry about that. We want the ID code. We have to get ID code C. That's good. Okay. Now let's just verify. Where's this has the block? I get rid of that. Okay, but let's just see. Update device, parse FRAD into memory, FRAD file. Okay, that should be good. I'm not gonna worry about the block. Git bin it. Okay, we won't worry about that. We won't worry about this. We'll keep that. Read ID code, read B scan. Okay, cool. This is all we need. Read frame. Yeah, okay, cool. Hopefully we can put jack to random fault. Okay, we'll have to put this code up somewhere so people can look at it later. Okay, so I think we're good. I just need to make sure. Okay, we'll try that. Okay, I think we're good. So what we're gonna go here is we're going to JTAG target to. Now we do this, that's highlighted. And then we're going to source init ARTY.tickle. Invalid command name. Oh, did we screw up somewhere? No, that's great. Where are we right now? Okay. So it didn't like one of those commands. So there's an invalid. So oh, it's probably that. Yep. And disable what? Running for it, disable what? Okay. Oh, we need. Okay, so if we do get ID code, which one are we getting? Oh, I think we have to do the whole. Where's our ID code? There we go. Do I need to do JCM light? I get ID code. Okay, and we want to do ID code underscore C. Okay, that's working nicely. Let's try test valid frames 0, 0. That looked like. Okay. And it returns. Okay. Does it? I need to see when it doesn't go in order. Seems to be going in order. Where's a jump? 2, 3, 1, 2, 3. Okay. Okay, good. There was a clear jump here. It looks like we loaded it correctly. So let's read a frame. Let's read frame 0. Read frame 3, 4, 3, 4. Inject fault. Okay, here we go. Now let's just see if inject fault works. 1, 2, 3, 4. Word. ACM light. Okay, cool. So it looks like it's working. I'll put the code up so we can do this otherwise. Okay, so let's show how we connect. Oh, sorry. So we're gonna quit this. Exit. We're gonna do xsdb source init arty.pickle. Okay, now we're connected, right? Cool. POF. Cool. Let's go grab the appropriate bit file and put it there. So this was in Dream. And when did we do this? No, okay, so let's go open it real quick. Can't remember where the bit file is. Okay, let's see. Okay, we want to go to this one. Let's check real quick with terra term. So we're going to do port 4, setup, serial port, that baud rate, new setting, open hardware manager, target. Okay, whatever. File, we're gonna export. I'm just gonna have to down, I guess. The git from presentation. Where's that bit file? Bit file. Is there no bit file? guess we can grab the TMR one real quick. Runs station. Here, grab that bit file. Go to this guy, drop it down, Kronos TMR bit. Okay, let's go inject that here, Kronos TMR bit. We do this, you can go here and watch that it loaded, and we can see the serial output here. But we want to see the serial output. Oh, I gotta do pi serial. Here, let's open this one. Okay. So in ARTY, and we're gonna do COM4 115 200 and let's do this. Okay, cool. Then we're gonna have to figure out what a correct value is. So let's do this again. Let's not reset the buffer, shall we? There we go. Let's go back to that reset buffer. Okay. Okay. So we're going to want to do during this, we're going to reset the buffer, program the FPGA, and then read the line. Okay, cool. Let's see if this is repeatable. Okay, so now let's try to validate our processor. Well, let's try to do a random injection, right? Do our random. That was a different test. Okay, let's go this one. Test valid frames. Okay. We're just gonna have to do inject random bit and then fix it. Do injection. Or do we not, are we not fixing? Doesn't look like we're fixing in this. Is there a way to, do we add something to fix the last bit? Because I might just add it. Inject. These are localized. I'll remove fault. We're just gonna have to target false injection. Okay. So let's do a random injection where that was up here. So random injection. Let's do random injections until the device stops. Feel like even though it's TMR, we should break something. Hit the 200. Curious, what are we seeing here? We're not seeing any at the moment. Okay, got the 200. Still going strong. Section. Is there a way? So it is doing. Otherwise, it's not printing it. Okay, I guess we'll just go to like 300 or something. Maybe I should watch the current on this guy and see what happens when we inject faults into it. Okay, is it still running? Ah, it finally broke it. Okay, cool. It broke. Sweet. Um, so we want to make telemetry key for values. What about the beginning part? That was for that one. We have different telemetry here. Yep. Let us start doing some telemetry on this guy. Okay. Then we're going to let's actually make a separate one. What we're gonna do is we're going to see what we have. Oh, so this Twitch, I might not have enough. I have to be a certain thing to do VODs on. I'll look into that. I'll look into Twitch playback. YouTube has all of everything. So if you want to watch playback, go to YouTube. Let me see. YouTube has playbacks. Cool. We'll work on the other things. Okay, so we got some fault injection going. So let's set up the key. Number of procs is 1. Okay, now let's going to say if m equals print. What do we want to print? We just want to print m, don't we? Let's print m. Yeah, okay, sure. Python 3. Okay, cool. And then we do that for matching. Let's do that group 0. Ah, okay, group 1. And then group 2. Okay, cool. Okay, so let's go ahead and do this. Let's do for x in range 20. Okay. Right. So we're going to take this. We're going to have golden is going to be, so we'll say right here, we're going to say old value equals 0 if old 0. Oh, we'll say -1, right? Yeah, if old value equals -1. I gotta set this up as an int though. Old equals what int? I gotta do what, like 16? Old is not, I'm sorry. Okay, yeah, and how did we parse these things? Did you int, okay, we're good. Else print um current value equals this. And we then print current's gonna be bigger, so we'll do current value minus old value, and old value current value. Cool. 40, 40, 39, 40, 40, 40, 40, 39. Okay. So now we're going to do a random injection. And we're going to say, yeah, right? It's going to equal yeah, Discord, I'm just keeping a record of documentation, and you can ask questions, project ideas, and stuff like that. If equals diff equals 39, or diff equals 40. Yes. Else print And yeah, just print that always. Okay, so let's go ahead and do this for some good telemetry. Let's do 400. That not clean out? That might have not cleaned out. 3847. That might have taken too long to get to it. How the clear buffer? Reset buffer not work? Probably was just a bad timing. Let's see if we do like immediate, like an immediate reset. Oh, we could do. Let's put this all on one line. Okay. So let's go ahead and stop. And what we're going to want to do is say injection equals, and then we're going to print okay, and let's print group 1 as well. Feel that. See how long it lasts. Okay. Hopefully, any more questions? Oh, we should try the weaker design right here. This one. Let's export the bitstream file to the C drive. Okay, ARTY right here. We're just going to call it. Okay, cool. Hold on. This is doing pretty well. I think the one is this if it's a success. Look at it real quick. Inject random. Yes, results. It worked. I don't think that's a 0. Check fault internal. Return. Yeah, if it failed, if it succeeded. Okay, cool. Okay, we stalled. We stalled. Really print out X, but it's 12E hex. Let's print out X as well. And let's do the normal bit file. And right here, let's just break. Kill that. That took 10 bits. Sheesh. In this situation, we need a timeout on serial read line. Need a timeout. How do we do a timeout? New serial. Okay. Yeah, we should look at doing a timeout. Okay. Oh, was it serial AOD? Oh, we should print this. Okay. Try this again. So it lasted 10 bits. So we're being kind of mean to it right now because we're not doing single bit injection, we're doing accumulation injection. But let me see. If we go here, right? Project. How much of the design are we using? 9%. We should see a small thing. We should maybe try using some of the essential bits. I can do that. We can look at doing the essential bits. But yeah, we have automated fault injection. I need to work on the script and post the script for that. Okay. It's going. A lot of fault injection to find a issue. That's surprising. Going pretty far. I need to what would be good results? We should do some accumulation testing like this. What run it 10 out of 10 times or something. Oh, it's gonna reach the end soon. Going to break. Good. Nope, it made it to the end without breaking. So make this rollable, and let's do a lot. want enable scroll. Want to stay at the end. Can I just like hit? You want to do the line? Oh, there we go. So it didn't change between those two iterations. Okay, that was pretty quick. Try another one. Now we need to fix it. Okay, while we're doing this, we have um right here, this scroll fix. Say if this whole right here not equal to 1 to injection here that and then we want to do inject fault. These are strings, so I think we should send. Oh, Python string. Been a while. So we want to do. Yeah, we just need to do these 3 things then afterwards. So just format. Okay. Format injection 0. I think, yeah, we're just going to do it. 0, 1, 2. Okay. Does the tickle script may need to pass the channel in? Okay, we'll see how it works. How far did you go? Made it to 302. Okay, let's see what happens. M dot. Okay. Are we seeing? Oh, we can see the fixing of it. Yeah, it looks good. Might want to slow down this. Okay. So what we want to do, put an and here, and injection 4. Python string something. Okay, we can just do an equals. 4 equals. Okay, and oh, sorry, it's supposed to be 3. Okay. frame. To do finish. A serial time. Okay, I need a serial read line timeout. Okay, we need a timeout. We specify a timeout 5 seconds. Okay, so gotta close it. Turn on your outputs real quick. Like an else here. Print serial string and error. Edit. Okay, that worked. So let's try to do multiple ones, right? So we're gonna do a for a y in range. Let's get 10 errors, right? But we don't want to print this. We want to print that and do it 10 times. I think so. This is gonna be really boring to watch, I guess. Yeah, progress. Have to add a progress bar afterwards. This is IPython. Sorry, I should pay attention to my chat better. I'll just send in the messages here. IPython. Okay. Yeah. Hopefully we get one error. Maybe we should grab progress bar. Progress bar here. And progress bar. So we got start and the progress bar X. Oh, look at that. Find it. So I have a progress bar. Okay, so let's see. Okay, so that took 90. We'll probably should get the sensitive bit out of these, work on that, storing the injection that caused the failure. Let's get sample 10 of this. All right, let's see if we can get it quick enough. We'll save a picture, and then we'll run over the TMR design and see, hopefully, some simple benefits. But so if we're doing 1000 X, we should do this at 1000, 10,000. Yeah, 10,000. So the value kind of lines up with my thinking. I guess that percentage works. We should watch this. This the look at all the frames go by. Doesn't print the frames. Not see. Then definitely, yeah, right there. What's up with that? Okay. This is the best part about fault injection. You just sit here and you'll watch as you slowly inject faults into the design. Okay, so we'll run this for a bit. Probably start the TMR one, end the stream, and you get this. You clean up the code, release it. Python notebook page working for it. Okay, yeah. Well enough. Or what the average percentage. YouTube does not like how quick my frame is changing. Oh, look at that. Those are interesting. Whoa. Fastest one yet? Whoa. That one actually even started correctly. That might have been a false one. But maybe not. The 0-1. Need to find a way, you need to like log these and look at these. So we'll say like 5%, right? Well, 5% of the progress bar, which equals what? Maybe 200 is how many injections it takes. So maybe like 0.5% CRAM sensitivity. Yeah, maybe less than that. 1, 2, 3, 4, 5, 6. Okay, let's get 4 more and start the TMR one. Maybe I should just let this stream on Twitch without any let stream overnight. That would be interesting. Have an active stream of stuff. I don't know what would happen when idle. Guess I could do like a specific window. Yeah, that's an interesting idea. Okay, we got 7 failures. Good. 3 more. you think of some other ideas we can throw into the fault injection to make it happy. We can do a validation phase when we prepare it. We can do targeted fault injection once we find it to validate it. We'll have to play around with a few techniques to try that. Okay, how many do we have? 1, 2, 3, 4, 5, 7, 8. 2 more we need to collect. Yeah, the average is actually lower. We'll probably say what, like 120, 150-ish. Less than. So as we're randomly flipping bits in the FPGA, we don't know if the specific bit from the specific injection caused the failure or if it propagated across another one. So we have to validate our results. We can't do one pass. We have to do multiple passes of same injection to validate it. But once we get these ones, we can run it through BFAT. So we should get some BFAT results. That's probably be what we want to do. So we want to get some sensitive bits, throw it through our little bitstream fault analysis tool to get some information. Okay. Oh no, that was done. Might be a certain stage where it flips over. We would have an issue. We might have. We'll see that the TMR design might have that. We have one more. I guess range of 10. 1, 2, 3, 4, 5. 2, 3, 4. Okay, one more. So the issue here I'm talking about is oh, I guess it's dying before it flips over. May have to count for that. We'll see if the TMR one consistently fails within a certain time frame. Technically, I think this could run on Google Colab if you opened up your port on your computer. Seems silly though to do it that way. Ideas. Okay, finish. Okay, let's take a little screen capture of that. And let's go ahead and run it with the TMR design. Hopefully the new one. Just go see if that new one was actually what it's expecting. Been recent. So we should be like a 40. Let's. Yeah, okay, cool. This has the proper voters to it. So maybe we'll sit here for a 1 or 2, but it should take, I think, about 10x. So like we up here, right? It should be 10x longer than those. How far behind this? Close. So at the top here, we have the unmitigated design, the normal design. Down here, we're running the TMR design. So we should, where we have these percentages, I expect 10x, right? I think we should get like to at least to 10% in our progress bar before we jump to the next one. So looking at this, I'm gonna say 20% by what we're gonna expect. We'll see if it goes that long. Be interesting if we understood what the data on the right over here. So this is the frame data from the FPGA. This is going to be your LUT, your routing tables, among other things. So it's promising we already got to 7%. So I wonder when it's going to flip over. We didn't account for the rollover effect. I should probably specify those cases. Well, looks like TMR is definitely working. How about this? We'll sit here as I monologue to myself. Once it 20%, we'll end the stream. Or when it fails. Let's see. Okay, so tomorrow evening we'll look at the analog pocket. We need to Okay, we need to do the gate mate on Saturday morning. Need to figure out what to do for the gate mate FPGA. I don't know. I don't have any good ideas for this board. Like, no good at peripherals. Do PMODs. What can we do with PMOD? HDMI is the most interesting thing. We want to try out their multipliers. There's also the HyperRAM. Why is it just in like a UART or something on this thing? What else could we do? Hmm. Look at that. Made it to twice. Great. Great results. Hmm. I don't know what to do with you. Guess we could do a UART. I guess we should try to do FPGA to FPGA communication. Grab the ARTY board here. Just try to write the LTDs. But how do we do like high speed? Maybe do a loop back. Um, no, if they have a clock capture. Oh, look at that. Still going. Okay, 3% until 20. That's probably a confident like 10x improvement. That's why I was hoping with this version of the TMR tools, about 10x improvement. But we'll see what happens. I think we still have to look at what the relative sensitivity is because different LUT sizes. 1% to go. And then we're going to call it for the night. And I may have to fix this in the morning and run it. But we'll see what the morning says. Do like a very special case. Okay, doing great. We're gonna end the stream here, and we can see you tomorrow. Good night.